Yo, what up, geometry students? We are going to talk about how 30, 60, 90 triangles, to solve them, to find the lengths of them, we don't need trigonometry because they're very easily found of a 30, 60, 90 triangle. We start with a equilateral triangle with side lengths 2. And we know equilateral triangles have 60-degree angles everywhere, including at the top. But what if I split this equilateral triangle into two 30, 60, 90 triangles? Well, all of a sudden we create this 30, 60, 90 triangle with the hypotenuse of 2, this 60-degree angle, this bottom length of 1, and then to find the middle side, we have to use the Pythagorean theorem. A squared plus b squared equals c squared. So I got b squared is equal to 3, b is equal to root 3. Boom. You now should know. And if you don't remember, you recreate it by taking a equilateral triangle, splitting it in half, and using the Pythagorean theorem. The side lengths of a 30, 60, 90 triangle. We notice we have a small, a medium, and a large. For any right triangle, there's usually a small, medium, or large. For a 30, 60, 90 triangle, the side length opposite the 30-degree angle will be the small length. You can use 1 as an example. The medium, which will be opposite the 60-degree angle, will be the root 3, and the large will be the hypotenuse opposite the 90-degree, which is 2. We are going to scale this triangle, okay? So I have 2, and then it goes to 1. I'm dividing by 2. So I'm going to divide all these sides by 2. The medium side length would be root 3 over 2. The short side length would be 1/2. Cool? That's it. Now, if you want this triangle, well, here's the 30, 60, 90 triangle that I know. It's got a small, a medium, and a large. The medium's opposite the 60 degrees. The small's opposite the 30 degrees. Oh, yeah, that's my 30, 60, 90 triangle that I know and that I use. If you want to scale that to get another triangle, what is the scale factor? We can see we are taking the medium side length of root 3 and we're turning into 1. That scale factor is going to be 1 over root 3. So the small length is now 1 over root 3, and the big length is 2 over root 3. Cool? So that's it. And then we have a 45, 45, 90 triangle. And the easiest 45, 45, 90 triangle is, first of all, we know that if it's 45, 45, that the two side lengths are going to be the same. Well, if I call this side length 1, this side length has to be 1. If this side length is 3, this side length has to be 3. The two leg lengths have to be the same. And then if you use the Pythagorean theorem, you'd find the hypotenuse is just root 2. Great. Well, scale that. Well, if we want the root 2 to turn into a hypotenuse of 1, my scale factor would be 1 over root 2. All of a sudden, we just start seeing that we have 1, 1, root 2, and then 1 divided by root 2, 1 divided by root 2. So it's like either multiply by root 2 or divide by root 2. You could do that. But I'm just going to scale the 1, 1, root 2. Okay, so again, saying this one more time. If you have a 30, 60, 90 triangle, you know that one example of a 30, 60, 90 triangle is 1 root 3, 2. All other 30, 60, 90 triangles can be scaled from that triangle. If you have a 45, 45, 90 triangle, well, let's call 2 of the side lengths 1. The other side length has to be root 2. If you have any other 45, 45, 90 triangle, you could scale it from this, okay? And that's what the rest of the homework is. Cool, it's a 30, 60, 90 triangle. I'm going to start with a small, a medium, and a large that just looks like this 30, 60, 90 triangle. With the small being 4, I can see that the scale factor for my triangle is 4. That means the long side is 8, and the medium side is 4 root 3. Okay, this 30, 60, 90 triangle, this taller orientation. Well, I have my 30, 60, 90 triangle with a small, a medium, and a large of 1 root 3 and 2. Well, I can see the hypotenuse is 6, so that's a scale factor of 3. So that means my short side is 3, my medium side is 3 root 3. Next, a 45, 45, 90 with a hypotenuse of 8. Well, my 45, 45, 90 triangle that I like to use is 1, 1 root 2. I could see that the scale factor would be 8 divided by root 2. So you can see that the hypotenuse being 8, the legs have to be 8 divided by root 2. If the leg was 8, the hypotenuse would be 8 times root 2. Whatever. All right, cool. Here's another 30, 60, 90 triangle. But now we got a medium side of 10. Well, my 30, 60, 90 triangle that I know and I use is 1 root 3, 2. Small, medium, large. I'm going to orient it the same way. So the small is 1, the medium is root 3, and the long is 2. The small is opposite the 30, the medium is opposite the 60. I can see the scale factor goes from the root 3 to the 10. Those are the corresponding sides whose ratio 10 over root 3 is the scale factor. So that means this would be 10 over root 3, and this would be 10 over root 3 times 2, which is 10 over root 3 times 2 over 1, or 20 over root 3. Cool. If this is a 45, 45, 90 triangle, well, this is 14 here. I know this has to be 14, right? This is going to be 14 root 2. Or you could start with a 45, 45, 90 with 1, 1 root 2 and say that the scale factor is 14. One more. 30, 60, 90 triangle. We have the medium side length is 3. Well, I know a 1 root 3, 2, 30, 60, 90 triangle. It must be that. You got to be able to know that it's that, memorize that it's that, or be able to figure it out. You can see that we are going from root 3 to 3. That scale factor is 3 over root 3. So this is 3 over root 3, and this will be 6 over root 3. Cool. What's the trig function of all of these angles? Well, all you need is one 30, 60, 90 triangle. 1 root 3, 2. And now you can have the sine of 60, the cosine of 60, the tangent, and you'll be able to double check it with your calculator. I'll show you in a second once I pull it up. I don't want you to use your graphing calculator. I want you to say, okay, if this is 60 degrees, the opposite over the hypotenuse, no matter which triangle I look at, will be root 3 divided by 2. Let's take this one. 3 over 6 root 3 would be root 3 divided by 2. Yeah, I can show you why that's root 3 over 2. If this 60 degrees, it'd be 10 over 20 root 3. It would end up being root 3 divided by 2. The cosine of 60 degrees is 1/2. The tangent of 60 degrees, opposite over adjacent, would be root 3 over 1, or root 3. Watch, I'm going to type those in, making sure I'm in degree mode. Now, I don't want us to do this. You don't have to do this. But if you did, we get square root of 3 divided by 2 is the sine of 60 degrees. Oh, just like I thought, 0.866. The cosine of 60 degrees is 1/2. Okay, there's my 1/2. The tangent of 60 degrees is this weird number. What is this weird number? 1.732. It's the square root of 3. Cool. So we don't need our calculator to understand these ratios. Now for a 45, 45, 90 triangle, where we have 1, 1, root 2. Since it's 45, 45, it's a isosceles triangle. Great. The sine of 45 would be 1 over root 2. It doesn't matter which one you look at. The cosine of 45 would be 1 over root 2. The tangent of 45 would be 1 over 1, which is just 1. Just like root 3 over 1 is just root 3. 1 over 1. 1 divided by 1 is 1. Back to 30. Let's go to the 30-degree angle. Sine, opposite over hypotenuse, 1/2. It's the same as the cosine of 60. The cosine of 30 is root 3 over 2. It's the same as the sine of 60. Why? Because they exist in the same triangle. And the tangent of 30 is 1 over root 3. It's the reciprocal of the tangent of 60. Cool. It doesn't matter which triangle you look at. You could type in all of these into your calculator, and it's equal to these values. Okay? Next. Cool. Find the values of A and B. These are just like questions that should not be looked at as tricky. If we have 30 degrees here, we can see we have a small, medium, large side length. We can identify a scale factor. I'm going from the short side of 1 to a short side of 2, so that's times 2. So that means this 2 times 2 is 4. 6a has to equal 4. Root 3 times 2 is 3b, so 2 times root 3 equals 3b. Then we have these equations to solve. I'm going to divide by 6, divide by 6. I get a equals 4/6, which is 2/3. Here I'm going to divide by 3 and divide by 3. I get b equals 2 root 3 divided by 3, which I can't simplify. That's it. It's that simple. You just got to solve for the value. It's not supposed to be too tricky. So here, if we have it oriented this way, I'd have a small, medium, and large. I could see that I'm scaling things by multiplying by 4. That means 3a has to equal 4, 1 times 4, and 4b has to equal 4 root 3. That means a equals 3/4 after dividing by 3, and b equals 4, b equals 4 root 3, divide by 4, b equals root 3. Cool. What about a tricky triangle like this? Well, you can see it's a 45. The other angle has to be 45. It's got to be isosceles. It's got to be 1 and 1 and root 2. Cool. Well, I can see the scale factor is going to be 12 over root 2. That means each side length is 12 over root 2. Not going to be easy answers, but we could do it. So we'll have 4b equals 12 over root 2. We'll have 3a equals 12 over root 2. I will multiply by 1/4. Or divide by 4. Multiplying by 1/4 is easier because I don't want a fraction inside of a fraction. 12 times 1 over root 2 times 4. I can divide the top and bottom by 4. Or just divide by 4 to start with, and I get 3 over root 2. Here, if I divide by 3, I'd get 4 over root 2. I could divide the 12 by 3 or divide by 4, 12 by 4. Okay, same here. If I have a 45, 45, 90, I could scale my 1, 1, root 2. And I can see the scale factor is 6, which means this has to be 6, which means a is 6 over 8, which is 3/4. And I can see 9b has to equal 6 times root 2. Divide by 9, I get 6 root 2 over 9. Divide the top and bottom by 3, I get 2 root 2 over 3. 13, an equilateral triangle has a perimeter of 18. If the perimeter is 18 and we split it evenly, these have to all be 6. Well, since this is an equilateral triangle, it looks like I'm splitting it in half. It looks like I have a 30, 60, 90 triangle. Oh, if this is 6, this is 3. If I have a 30, 60, 90, I know that it's 1, root 3, and 2. So the scale factor is 3. If the scale factor is 3, this is going to be 3 root 3. Height of 10 centimeters. What is the perimeter of the triangle? Ooh, what a good question. All right, well, we know that this is a 30, 60, 90 triangle inside of this equilateral triangle. And I know that we have a small, medium, large, 1, root 3, and 2 that can be scaled. So my scale factor is 10 over root 3, which means my hypotenuse is 20 over root 3. Well, that means all of these big lengths are 20 over root 3. So I'll have 3 times 20 over root 3, which is 60 over root 3. Okay, and we'll just end like that. We'll talk about how back in the day, before we had calculators, we did something called rationalizing this. But I don't worry about that. Cool, an isosceles triangle. What's the height? All right, well, I can see we have this, which will give me this length here, but it looks like we have, within a 45, 45, 90, another 45, 45, 90, which is fun, which means if I have 1, 1, root 2, I could see the scale factor to get this height is just this length. So the scale factor is 10 over root 2. So the height is 10 over root 2. Fun. If this is 20, well, I can see a 45, 45, 90 here. That means this is 20. And this is 20. So this bottom side length is going to be 40. And if this is 40, I could say this is 40 over root 2, or I could say this is 20 times root 2, and we'll say that they're the same. because they bar. But the perimeter would be just like the sum of these three values. You could say it's 40 plus 20 root 2s plus 20 root 2s is 40 root 2s. Or you could say it's 40 plus 80 over root 2s. If you compare these two values, you get the same answer, okay? But guys, I don't know, like, I hope we're not feeling that this is too hard. You just have to know how to scale triangles, which is what we've been doing the last 2 units. You're either scaling a 1 root 3 2 triangle, which is a 30 60 90 triangle, or you're scaling a 1 1 root 2 45 45 90 triangle. All right. We have a longer quiz. Next class, we'll review for it, but then it's all on you. Okay? Later. Peace.